Hello everybody, and in this section I will introduce you guys how to just conduct for the forecasting methods on Excel. Basically these chapters I will try to just represent all the calculation based on the two methods. The first method could be the moving average, right? And the second method I will with the same data from the same chapter with Rush Goldrat. I will use another one, but this will be the exponential smoothing. Okay, right, and at the same time I will try my best to try to wrap up everything that to make sure you guys can understand it, the way to just calculate for the forecasting accuracies of the model. So let's come with the first way. Let's can do it with the moving average, right? So I do it with the moving average. So right here I will say moving average equal to the order of 3. That means we will use the 3 continuous day to measure for the average values, and we use that for the forecasting value for the next period. So over here I use the average function, and I just simply select for the 3 period before, and here we have the result, right? Here we have the result, and let's go to check if that would be something looks similar. Let's do it with the similar moving average. Yep, this will be the way for people to calculate for the moving average of the next period with the m order equal to 3. Okay, and our work would be like just have to copy all the data. Okay, and actually we can measure for the forecasting of the next chapters, like in the next the week 11, even when we just have the data up to the week 10, but we can still do it for forecasting for the week 11. That's one period ahead, right? Okay, right, now let's just go and gonna check like how it look like for the another way that I can do. So I can do for the MA moving average method, but however now I can do it with the computer. Actually the Excel there has been already integrated a function called moving average in the data analysis bottom, and you can select for the moving average. Okay, this is the moving average, and you say okay in the window, so you can easily select for the data. Over here I had the original data of the cell from the first week into the week number 10, and remember to put like label in the first round, and I want to do it for the moving average of 3. So that would be what I say, put it here 3. Okay, and I select for the output range. The output range should be star whatever you want, and you say okay. But however now you can see it like that, some kind of different, and this is why, because for over here, even when the computer of the Excel has been already calculated based on the data up from B2 to B4, that means from week 1 to week 3, but however they allocate right in the week 3 for the forecasting, and that's not what we plan to do, right? So very simple, just move it one cell forward, and now all the calculation is totally the same. All right, that will be the point. Now I show you how to do for the forecasting accuracy measurement, right? We want to do it, and we want to check for the if the model is very good. We base on the forecasting accuracy criteria. Okay, so what I want to do would be the MAE. That means the mean of the absolute errors. Another one, MSE, the mean of the square errors, and the M would be the MAPE. That means the mean of the absolute percentage error. We first of all have to measure it all by ourselves, right? So how we gonna do it? So first of all, we measure for the forecast error. Remember, forecast error will be the difference between the actual data. Here the forecasting of the week number 4 will be 116.67, and the actual data that's provided by the historical data, that will be 120. So the difference would be the 120, the actual data, minus for the forecasting data. And this is how we're gonna do for the forecasting. Okay, of course we can do with the other one, and we cannot measure it for the values of the week 11 because we don't have the actual data to measure for that one. Thus that could be the forecasting error. However, we normally do for the mean of the average, absolute mean of the absolute errors. So we need to measure for the absolute error. Okay, the absolute error can be easily measured by some kinds of function, but over here we just use like ABS. Okay, and I just select for the forecast error, and we repeat copy for the formula for the next cell in the data. Right, so over here, if I want to measure for the mean of the absolute errors, I just use average. Okay, and select for all the data of the absolute error, and this could be what I say. Okay, this will be what I say. Let's go and check like if there kind of anything like different. No, this could be something like that. You can actually do the sum, right? The sum for all the absolute error, and then you measure it by divide for the number of the forecasting values. But however, I prefer to just use it like average, and they can automatically calculate for me. That's the reason why. Okay, let's go check for the accuracies of my calculation later. Okay, another one, if I want to do it, I will have to use for the square error. Okay, the square errors will be the way for us to, instead of use the absolute errors, we square it on, and this will be how we're gonna do it. So very easy, you just use for the forecasting error and then just square it up. Okay, power it for 2 or something like that, and we can easily do it and measure it for that way. Okay, so with the square errors, we can easily measure for the mean square errors, and we just use for the average function. Okay, for all the square error, and that's how we're gonna do it. Okay, last one, the absolute percentage error. So if we want to do it, we have to make sure that we have the percentage error first. Okay, the percentage error will be how we can do it. We divide it for the percentage of the forecast errors, and then we divide it for the actual data. Okay, and this will be how we do it. Turn it into percentage by just some kind of a small trick, and we have the percentage error. However, because of the percentage error, when you get sum up and do for the average forecasting, they can have some problem about cell elimination. That means the minus values and the kind of like normal value, they can eliminate it other, they can terminate it other, and that would bias for our kind of calculation. Sometimes that's make it too small to just measure on that, especially when the data quite symmetric and they easily have some kind of like a mirror values that totally the same with them but have different direction. So in those cases, the people don't really base on the percentage error to do all the calculation. So they generate for another values that should be absolute percentage error. Okay, and that's how we're gonna do. Okay, and just very simple. One more time, absolute function of the percentage error. Okay, and you turn it on, turn it into percentage, and they will be here. Okay, and here we go. we just need to do for the mean of the absolute percentage error equal to the average of all the absolute percentage error. And that's how we gotta do for the calculation. Okay, they do it over here by themselves, and all of them can be pretty the same with what we are doing. Okay, so I will show it up here, and you can see all the calculation. Maybe there are some kinds of different because they can do for some kind of rounded before they do for the calculation. I do it based on Excel, so I'm pretty sure that and confident that my calculation could be a little bit get a higher accuracy rate compared to the thing that the book is providing. Okay, let's do and practice it one more time in the exponential smoothing. And with over here, I will not spend the time to do it. Just do it all by ourselves, right? So exponential smoothing, and over here I would just assume that right over here the people with the example they use for the damming, okay, the dam slope, okay, will equal to 0.8, okay, 0.8. So I put it here 0.8, and that means of course the exponential smoothing when they do for the calculation in the next values will be how we can measure is based on 80% of the current values, the closest values. So if we want to measure for the with 3 values, right, of the cell, so of course we have to make sure that we have the data of the with 2 and with 1. With 2 will be 1 period before, and with 3 with 1 will be like 2 period before. Okay, and I use for the next one will be, okay, I will use for this number 80, but I will fit it, and then time for the with 2 a period before, plus for 1 minus for the dam values, but F4 to fit it, and time for the with 1, that means the 2 period before values. And that's how we can measure for our calculation. Okay, let's check it. If like this one over here, that will be alpha equal to 1 and alpha equal to 8. Let's go and see the check it if they are very close to each other. I think like they the same. Okay, and with the same way they measure for that. Okay, and that's how the people do it. Okay, with the alpha equal to 1, and here that should be alpha equal to 8. With me here, I prefer to use for alpha equal to 8 more. Okay, and with this, they will automatically assume that the data will be the same with the previous one. Okay, 100% based on 100% based on the with 2 will be based on the number 1 values. Right, now let's do it with the another way that the people can do it for the exponential smoothing will be you just put them into the data. And one more time, instead of the moving average, now you use for the exponential smoothing, and you select for the data over here of the cell values, and the damping factors I put it like 0.8. yeah, that's right. And the output brand I want to put them here. Okay, and I say okay, and you can easily see that this will be how the people doing for the measurement. Okay guys, sorry about my mistake, but I think like with exponential smoothing and damping factors, when the people have get the exponential smoothing alpha equal 8, that means the damping factor instead of 0.8 you have to put it like 0.2. that means 100% and minus 4 80%, and that's be the reason why it will be here will be like 0.2. and I will replay my result, okay, based on the previous, and the data will be automatically generated for this way. Okay, yeah, that's look correct. Right, Yeah, that's right. This will be how the function will be worked on, and you can do it with this one. And one more time, I can easily do for all the forecasting based on the criteria of the MAE, MSEs, and MAPs. Okay, so I will do it very quick. Just do for the forecasting error, right? And this will be how it's good look like. Okay, absolute error based on the forecast error, right? Square error, that's mean based on the forecast error, and then square it up. This is how it look like. Okay, percentage error, the difference between the percentage of the forecast error over for the actual values. Alright, and last one, absolute. Okay, but however I train it into the percentage symbol, so that will be easier for you to understand. And now the mean of the absolute errors, I would just have to use average of all the absolute errors. Okay, this will be it. Another one, mean of the square errors, average of the square error. This will be it. And last one, the mean of the absolute percentage error. And ta-da! Okay, let's check it if that's correct or not. And I'm pretty sure they are very close. Even when they do it, make it for some kinds of like they round up, but my values, I believe like they quite the same with what I do it. Okay, and this will be how I already demonstrate for you about the way for you to do it for the moving average. Okay, the moving average method for forecasting, and another way could be exponential smoothing method on Excel, and how you can calculate for the forecasting accuracy criteria. So based on the two model, you can see like for the forecasting they have a smaller forecasting based on the moving average, they have smaller error compared to the exponential smoothing, right? You see like for MAEs, they have this will be smaller than the one of the generated of the exponential smoothing methods, and also for MSE they're smaller, and MAPE they're smaller. So you can say like the moving average they generate for the result with the better result, that will be less different compared to the actual data, and we can say the moving average will be the better method over two of them. Okay, right, this will be the one that I want to just convey in this class. Thank you so much.